Hello and welcome. My name is Bob Tickleman. I'm a Microsoft technical trainer, and I'm excited today to present to you this session on what you want to know when you want to know it. Today, we're going to be looking at Microsoft Azure infrastructure, and we're going to be doing it in the guise of the AZ-305 architecture course. This module is going to focus on business continuity. Now, this is much more than just backup. It's more than just disaster recovery solutions that you're going to build. We're going to take a look at a full range of traditional services that you might be familiar with, of providing some level of redundancy in your application design. Maybe you got a backup disaster recovery site that you built. We'll show you can do something like that. But we've got a full range of backup and recovery and high resiliency and continuity, consistency features built across the whole services that we've covered in other modules, whether it be in Azure Storage, whether it be in PaaS offerings of SQL servers that we have automatic backup capabilities in addition to the ones you have. So absolutely, backup and recovery, that traditional method that you backing up your services, is a huge feature that you might still want to continue, and I strongly recommend that you do. Now we're going to take a look at some of the built-in capabilities we've talked about in previous lessons. We looked at blob storage, and not just the backup of them, but we looked at the high availability of having local copies, redundant, 3 copies locally, zonally. You can have globally redundant. You could copy these off. We have snapshot capabilities. So we have both blob and file storage capabilities built into that storage account. We'll take a look at backing up your virtual machines as well. So if you've got that traditional IaaS or infrastructure as a service environment, we've got capabilities built into those services. And then, as I was just talking about, inside of these different offerings of SQL, other than that IaaS version where you're going to be responsible 100% for it, we have some natural native, automatic backup capabilities through the range of SQL offers that we have, whether it be a managed instance, whether it be a database specifically, and you still want to augment that with potentially your own backup, but know that there's some native capabilities. And then there's a feature called an ASR, or Azure Site Recovery. Now, this has been used widely. It's been around in Azure for quite a while. And in a way, it was a way for people to do migrations. They used to use Azure Site Recovery to create a replica, a disaster recovery component of their on-premises environment to Azure. And they literally just turned off their on-premises tool and failed over to the Azure Site Recovery, making it the actual production site. Not what it was meant for. We've got tools that I'll be introducing later on that get into this specifically and can do that for you. But we'll take a look at Azure Site Recovery as part of your backup and disaster recovery capabilities. When you take a look at backup and recovery, it's often the last thought that people have in an architectural design. And in fact, it should be one of the very first things that you take a look at. And I'm going to make reference to things that we've talked about throughout this series of courses, because you can architect a lot of what we're going to try and back up and recover into the architecture itself. And so we want to make that reference to, from a traditional perspective, how you might take a look at using Azure as the first line of defense, but backup and recovery still is an important part to take a look at this. And so you want to take a look at the different types of workloads and what's going to happen. And I'm going to make this reference into everything that we've talked about in Azure. So I'm going to go off and just make sure that you understand some of the concepts that we've talked about in Azure that's available for you that don't circumvent the need for a backup. But if you layer this approach where a backup becomes more appropriate, knowing that if you've deployed things properly inside of Azure, this will help you. So what you're seeing on the screen is an example of a region. In fact, this is US East, which is probably one of our largest region. The top bubble you're seeing was as what it looked like in 2014. And you can see the number of data centers that we have. And you also see a bit of the generational change that's happened with the data centers over time. These were our Gen 1. What you see is a whole bunch of smaller ones here. These were our Gen 2. In our Gen 4 data centers, this is what it looked like in 2017. So you can see they're 8 megawatts in size, just massive capacity. And where this comes into play is we've talked about when you deploy things in Azure, do you deploy it into multiple regions? And so US East is a region. We can have redundancy within the region itself. And we're going to talk about a thing called zone redundancy. And I'll come back to this one in just a second. So when we take a look at what is zone redundancy, inside of a data center, so what I'm showing you here is inside of data center number 1, whichever one that is. So think of that picture I just showed you. We get what are called fault domains within the data center. They're called scale units in our world. You're probably used to using the term called a rack. So every fault domain has a single point of failure, and we want to engineer around that. And so this scale unit, we have a thing called a TOR, or top of rack switch, and a PDU, or power distribution unit. They are redundantly connected to separate power and internet connections. So this scale unit is connected networkly and power through redundant capabilities, but the scale unit itself becomes the fault domain. So all of the nodes that are in it. And so within a data center, within a region, we deploy resources across multiple fault domains. And so when we talked about Azure storage being locally redundant, what we did is we put 3 copies of that file across 3 different fault domains. So I had a file, it would be 3 copies across 3 different fault domains within the same data center. That way, if I lose one fault domain, I still have the file. When we talk about zone redundancy, what happens is we now have multiple zones within the region. I'm going to go back to that other diagram. What you're seeing here is, in that diagram, for you and your product, if you had that file, maybe data center, and you don't get to pick this, you just pick, I want zone redundancy. So now instead of putting that file across 3 fault domains in a data center, it's going to put that file across 3 fault domains within the region. And that way, if my fault now becomes the data center, I now have zone redundancy because another data center within the region is going to be able to provide that data. Now, what happens if the entire region goes down? That's where we get into having your resources deployed across multiple regions. So hopefully that provides it from a context, not of just engineering the solution through other modules, in relationship to a backup solution. And where we're talking about this in this slide, you want to consider the workloads and how you've architected the solution. Do I architect the workloads and the usage as a regionally or globally based redundant capability? And that provides part of my backup and potential recovery solutions. So hopefully that leverages some of the other learnings that you've done in here. Take a look at the patterns of usage and take a look at these terms called MTTR, or mean time to recover, and MTBF, or mean time between failures. There's actually about 5 or 6 of these mean time between failure, mean time to recover, mean time to repair. They've got all these different numbers and they mean slightly different things, because if it takes down a data center, it's going to take you 3 hours to repair it or to recover it. All of these have different impacts for you. There's a thing called an RTO, an RPO, recovery time objective, and a recovery point objective. And they typically work counteractive to each other. The time to recover something might impact the point in which you can recover. I need to recover it very quickly. So my recovery time objective is I need it very, very quickly. But it means you might have to give up something, usually the amount of data, to get it that quickly. And as I said, they don't always, but they often work juxtaposed to each other. And you want to be a bit careful because people back up thinking about the time it takes to back up because they do it every single day. And they don't think about the cost of what it's going to do to impact the time to recover that information. So a classic example of this, again, if you take a look at different backup strategies, if you take a look at a typical backup and recovery strategy, what people do is they think about the time to back up. So I've got a whole set of data here that I need to back up on a regular basis. They back it up maybe on Monday and they do a full backup. And it takes quite a while to do that. So they do a full backup on Monday. On Tuesday, they may do an incremental backup. So all that's going to happen on Tuesday is what has changed between Monday and Tuesday. So all you get is the delta difference between Monday. On Wednesday, they do another incremental. All they get is the delta changes from Tuesday. So the speed to back that up is very, very quick because maybe not much changes. Goes back to the slide where it says, take a look at the workloads and the frequency in which information is changing. So this makes it very easy for you on a daily basis to back this up. But the problem with this is the time to recover. In the need to recover this information to actually Wednesday, my last backup, what I have to do is I have to recover the last full, so that takes a period of time. I have to then recover the incremental, that takes more time, and then I can recover the Wednesday. So the time to recover might be longer than what you're looking for. So what you might have to do is do full backups every single day, because now I can just use the last full backup to recover this. The other potential problem is what happens if, in this model, I back up on Monday, I do an incremental on Tuesday and an incremental on Wednesday. I do a recovery of Monday. I try and recover Tuesday, but it's corrupted. And so what you've now done is you've limited your capability because even though Wednesday might work, it's dependent on the Tuesday recovery. And so your recovery point objective might not be able to be attained. And so that's hopefully an explanation that a lot of people maybe misunderstand or think that they know, but this has a huge impact on your recoverability of the data of that recovery point, recovery time objective is looking at how the things are going to be working for you in your solution. So take a look at all these different components, architect the solution using Azure services, make them zone redundant, make them globally redundant, because that's going to be a great point in Azure to be able to do a lot of this stuff natively and without having to go through a traditional backup and recovery. Now, absolutely doesn't mean that you do not have to back up or recover. You must perform those activities because data loss, corruption of data, accidental or intentional, if people delete files, if you don't have a way to recover those files, it's going to be a big impact on your organization. The other thing is not only should you back up, you should practice recoveries. And that is a critical part. I've sat with customers and this one gentleman actually said, look at me, and I'm watching him and he goes, yeah. And I'm going, what's going on? He goes, I'm backing up. I went, yeah, so what? He goes, I got my eyes closed. And he was joking, but he does it every single day. He backs up. And I said, well, when's the last time you restored? He goes, I've never had to do it. I said, well, good luck with that, because life has taught me that the first time you're going to have to do something, it's going to be the worst possible time for you personally and possibly the worst time for the business. So it might be a year end or a month end, and maybe it's the day before your child's birth, and you're going to have to do something that you've never done before. Good luck with that. So not only should you do regular backups, you should do regular restores to, one, validate that the content of your media that you're recovering from is valid. Going back to the example I just showed you that the incremental might not work. And two, you're developing a skill so that you know how to do it. I can't tell you how many times I've been called out to customers to try and recover from a situation that was made worse by a recovery that went incorrectly. We had one case where they were trying to recover a single instance of a database, but they ended up recovering the entire SQL server and wiped out 5 other databases. So be very careful, follow these best practices, and do take backup and recovery as a very serious operation. Today, we're taking a look at Azure architecture and specifically designing for Azure backup, what this tool is going to provide for you. So let's get into this. For decades, hopefully you've been using some type of backup software on premises. As we start to move to the cloud, how do you back up the resources and your data sources inside of Azure? You're not going to be able to install backup software. I guess you could on a virtual machine and use it, but we've built in a backup capability across the Azure platform that doesn't only work for Azure, it is the backup service that you can use in a single pane of glass to back up everything in Azure, to back up everything in your on-premises environment if you so choose. So the backup service is predicated on a thing called a Recovery Services Vault. And we're going to take a look at in a demo how to go through in a hierarchical structure, build a proper backup solution to meet your architectural design requirements that we covered in a previous module, looking at all the aspects, because you don't want a one size that fits all. You're going to have different backup strategies for regions, for the type of data, the frequency that the data takes a look at, the volatility, as well as the value of the data. Maybe test data is not as important as your production data. So having all those things take place, we'll go into the portal and show you how to actually set up this backup service and use it to deploy. Today, we're taking a look at Azure Architecture and specifically some of the built-in backup capabilities and recovery that are built into the blob services. Let's get started. In previous lessons, we've covered the Azure blob services, and we take a look at a thing called a storage account. Within a storage account, you get a container, and within the container, you get the individual blobs or files that it maintains. Microsoft has built in some built-in backup and recovery capabilities of the objects that are stored in the blob container. Now, while these are great ways to be able to protect your data, it does not circumvent the fact that you may still need to perform a regular backup of this information. As capable as this is going to be, as I describe it to you, you still want to perform a regular backup, which we covered in another module. What they're showing you here is a series or a hierarchical structure built into the service of Azure Blob Storage that allows you to set up things called soft deletes and versioning. So starting from the far left-hand side, at the container level, you can create a soft delete definition that would apply to all the objects in that container. And there may be many. In fact, there's almost limitless numbers of objects that can exist specifically in any one container. Within a container, you can configure that if an object gets deleted, I can actually have a soft delete at the container level so that if the container gets deleted, I can actually recover the entire container. That soft delete by default then can be inherited down to the blobs inside of the object. You have to be careful because if the container gets deleted, you will then get it back to the last point in time that the container existed. You got to be careful because if I'm trying to recover just a blob that was in the container, you could potentially damage something that wasn't in the container at the time that the last soft delete came about. So, there's all sorts of configurations you can do to set this up. At the blob level, you actually have those same characteristics. So if a specific blob was accidentally deleted, it's like a trash can being able to go back in and pull that version or that deleted object out. Now, in addition to the soft delete capabilities, we have this thing called versioning that you can enable. Now, you can actually have for every write operation, a new version of that blob be iterated. Now, we recommend that you don't keep more than about 1,000 of these. You can potentially have more, but anything more than that could impact the performance of calling up that data and all the versions you're dealing with it. So you can set up some policies to get rid of older versions. But every write operation, you could version that object so that you can go back to multiple changes. So as opposed to a deletion, if you make a change, maybe you deleted a paragraph in a document and you made other changes in another document. Well, I want those changes, but I want that deleted paragraph back. So you could possibly go back to a version, bring it up, gives you some more flexibility around that. So make a distinction between versioning versus the soft delete capabilities. Now, again, that's built into the storage account capabilities, which does not circumvent the need to potentially back this up. In addition to the soft delete and the versioning capabilities, there's a point-in-time restore feature that you can also enable on the containers that you're working with. And so again, this becomes a snapshot that takes the information and copies data from one storage account into another storage account that you could then use to recover from. Those soft delete and the versioning features happened within the container that you were dealing with itself. So this is another layer of security that provides the blob capabilities of replicating that information to a different storage account and then being able to have a point-in-time recovery of that information. Today, we're taking a look at Azure Architecture and specifically the Azure File Services and its backup and recovery capabilities. Let's get into this. We saw in a previous lesson the blob storage capabilities to have soft deletes and versioning. Azure Files, as part of the storage account capabilities, Azure Files are slightly different in the way in which it works, partly because of the underlying protocols. Your file shares, you want to create them with backup in mind because it goes to that whole backup strategy of how often the files are changing, the sensitivity of the information. What we have is the capability of using a snapshot capability on demand. If you're familiar with the term called VSS or volume shadow copies, what it does is it's a service that captures at a moment in time a copy of an object, even if it's open, and it creates a snapshot of that object at that moment in time. Snapshots are fine and are at the file share root level. So in a file share, if you have subdirectories and subdirectories below those subdirectories and file, it is at the file share level. So at the root of that level that you're dealing with. And again, that's why we talk about create this feature, considering and break your file shares up if you don't need to take snapshots as frequently. So don't bury a file or a folder well deep down that never changes. You might be better off to have that in a separate share itself. Now, what you can do is still use your backup as part of a backup and recovery services vault to back those files up to a backup in case you don't need that or don't have the information in the snapshot file you're dealing with. We're going to talk about Azure Architecture and specifically the backup and recovery features available on a virtual machine. Let's get into this. Similar to other backup features that we've looked at separate from file shares and blob storage, there's some specific considerations you want to have around the virtual machines themselves. I want to introduce two specific terms that deal with what is called crash consistent and app consistent and file backups. You'll see that as the third bullet point on the slide. App consistent versus crash consistent deals with the state of a virtual machine that you may want to consider the difference between them. A crash consistent backup and recovery says that files written to the file system, in this case of the virtual machine, are in a consistent state across all the files that are in there. So any file that depends especially on another file to be in a consistent state, and crash consistent says at the time of a crash, we are going to be able to have that information brought back to that point in time for the crash. Anything that is in resident or not written to yet would not be available. And that's where you're going to get the difference between an app consistency. It takes a bit more work, but there are different forms. So the words here, it's maybe just nice to have an explanation of those. You're working with the volume shadow copy and the snapshot capabilities at the running state of a virtual machine at any given time. It takes a snapshot of that virtual machine using the volume shadow copy services. That snapshot is then available that we could then use as a backup to the recovery services vault as part of a backup process. So you want to group your VMs into customized backup policies depending on the states that you want to take a look or work with them. You want to consider, do I need to back up the data that's on the files or on the VM, or do I need to back up the VM itself? For example, if I have a VM that has a consistent set of applications and patches that are applied to it, and the files are changing on a regular basis that it uses, do I need to take a snapshot or a backup of that VM on a regular basis just to get the data that it's holding? Maybe. If I have a backup of the data, I could possibly go back to a machine the way it was several days ago. So you want to take a look at what is that's changing about the virtual machine. Maybe what I do is before I patch a virtual machine, I take that snapshot of it so that I get it looked at it just before I applied the patches. And then I take another one just after a patch so that I've got a pre and post. So in case I need to go back to either one of those states, I've got that information. So there's an example of some of the things you might be able to do from a VM snapshot perspective to be able to work with this. When you take a look at the consideration of a cross-region restore, or that CRR that it talks about, when you deal with a thing called a region pair, we talked about this in another module. Region pairs are a service that is managed by Microsoft that you don't get to pick the region pair. I'll use North America as an example. US East is paired with US West as the two different regions. US East 2 is paired with US Central. And we do that for a bunch of reasons that I won't go into right now. But if I deploy a resource into US East, and I make it globally redundant, it's going to be then paired with US West. And so a cross-region restore says that if I were to lose the entire region of US East, I need to be able to restore that service into US West. And so all of these features are there available for you in consideration of your virtual machine backup recovery, in addition to the deployment of that service in possibly a multi-region environment. Today, we're going to be taking a look at Azure Architecture, and specifically the backup and recovery features as they are centered around an Azure SQL service. Let's get into this. As we've seen across a variety of other services, there are some specific considerations as part of the backup and recovery service of Azure Backup. We want to take a look at how you might want to consider that model for SQL servers. Going back to a module that we covered with SQL databases and SQL managed instances as a platform as a service offering, there was a built-in backup process that was offered to you as a platform as a service offering. Now, those backups are going to be managed for you at a time that you don't get to set. So you're seeing some values that are there. There's a full backup that's done once a week. Well, when on that once a week? Is it the day before you start your work? So you might not have control over that. You then get differential backups every 12 to 24 hours. And for the transaction logs, you get every 5 to 10 minutes. So that is a great process that you don't have to worry about. It's in the background for you. But if you have different needs for your SQL server, you're still going to want to potentially have an Azure backup solution specifically for those needs on top of the built-in services of the PaaS offerings of SQL databases and managed instances themselves. So understand that, am I backing up the SQL servers? You don't have to worry about that. That's going to be part of that backup possibly. And then you have to take a look at the data versus the transaction logs and how that's going to play. So this is understanding what is available for you by Microsoft, and then how I might want to augment that with my own backup cadence to meet my specific demands for the use of data and the infrastructure that they're going to use. Today, I'm going to be talking about Azure Architecture, and specifically what you need to do from a recovery using a utility called ASR, or Azure Site Recovery. Let's get into it. ASR, or Azure Site Recovery, has been a utility that's been around almost since the inception of Azure. And what it was meant to do was provide site recovery capabilities, and also has been used for ways for people to take on-premises workloads and move them into Azure. Not really what it was meant for. And people have even used it as part of a backup strategy to be able to replicate information. Now, I think it's a bit of an overkill from a backup process, but let's take a look at what ASR is, what it's intended for, and whether you use it for that specific purpose or beyond that it would be up to you to decide and work with. So what this was meant for initially was to take on-premises environments and provide Azure as a site recovery, or a DSR, disaster site recovery model that you might be working with. Some of you might be supporting disaster site recovery infrastructure where you've actually got separate facilities where you're building infrastructure. And in case of your main site going down, you could always use that backup recovery site to run your operations. What we were trying to do was say, hey, listen, why do you have to buy those buildings or rent those buildings and facilitate them and manage them? You could do this in using Azure. So ASR is a way to take usually an on-premises model, or you can even use it from Azure to Azure if you needed to take a whole set of infrastructure and not just individual components. You could define maybe a whole set of servers, whether they be some mail servers and SQL servers, or front-end servers and app servers. You can take that infrastructure and as a totality, replicate that information from one location to another. And in the case of disaster recovery, it allows you to then have automatic switching. So what it will do is you define the infrastructure, and there, maybe I should, if I could remove that X, it takes the on-premises infrastructure, replicates it exactly into an Azure environment, an Azure region. And then what it does is it usually shuts down in the case of virtual machines. And what it does is it does a caching of any data changes in the primary site that you're working from. And it replicates that at a time frame of your discretion. So it could be every hour, every 10 minutes. So you can determine what time it ships that data from the change location in the main location to the site recovery location. And it monitors the use of the site recovery of the main site. And if it were ever to fail, it spins up that information in Azure and then points the request to that new infrastructure as it's spun up. Now, this is where we also get into terms that talk about crash consistent and app consistent data replication. So those are two features that you can set on the site recovery features, which I'll be showing in a demonstration shortly. So when we talk about, do I just ship the written files that are going to be there for a crash consistent state, but we can also get an app consistent state shipped across to the ASR site. In addition to using ASR just to replicate that information, we can layer on top of that an Azure backup solution to come along to help recover potentially some of the data. Because as I said, depending on the ASR configuration, how often is it going to transfer that data to another location? And what happens if you're transferring corrupted data? And this is why you may also want to consider a backup recovery process as part of that, because you may not know that you're replicating bad data to the ASR site. And if your main site fails, you basically have a corrupted recovery services site, and you may need to be able to go back to a backup to recover that. So that's just kind of a layered approach on top of that. So there's the wide range of BCDR capabilities that you're working with. And we now want to go in and do a demonstration of a number of them. We don't have time to get into all of them in depth. Looking at backup recovery vaults and all of these features, know that there's whole courses that get into that. Currently, AZ-305, the course Azure Administrator would be a good one to take a look at to dive deeper into the backup and disaster recovery capabilities and the business continuity as the BCDR features. But I will do a kind of an example of all of these features and how they play into your overall architectural design. Backup is one of the features of Azure that has evolved significantly over time, constantly adding new features, capabilities, and benefits. The Backup Center is probably the best place to start your journey as opposed to the individual tools. Let's start our backup journey by working with vaults. To create a vault, you first of all have to pick the type of vault that you want, a recovery services vault or a backup vault. They do make a difference based around the type of service that you're trying to back up. Take a look at this list and make sure you've got the right type of vault for the type of service you want to back up. Now that I've got a vault, I'm going to create a backup policy. I need to give it a policy name. I'll select the vault that I want to back up to. I want to pick the schedule that I want to work on and then create it. Now, while this is being created, I just want to let you know that I had previously gone into that storage account and I had enabled the service account as a backup contributor onto that storage account. So it's created the daily backup policy. Now I'll create a backup instance. So I've selected all the information of what's the data source type, what's the vault that I want to back this up to, what policy do I want to use, and then I select the data source. And it was this account that I had assigned that backup service contributor role to the managed identity. It'll go through and validate, make sure that everything has the necessary permissions to do the task that I'm asking for. So it's now passed all the checks and has the necessary permissions to do what it needs to do. And I can configure the backup. It's in the process of configuring the protection. It's now past that stage. So just to recap, you create a type of vault. And remember, there was two types of vaults, where there's the recovery services vault and the backup vault. Once you have a vault configured, you then configure a backup policy. And through that merging of the policy with the vault and then selecting the resource that you want to back up, you create the backup instance. In addition to backup, we now want to look at some of the features that are available in storage that will allow us to recover items as well as to enable versioning. At the storage account level, we want to take a look at data management and data protection. We have the capability to enable for backup of blob, have a point in time restore for containers. We can enable the soft delete for the blobs and enable soft delete for the containers. Those are the two we talked about. So can I recover the entire container? And you'll see that the retention for this by default is at 7 days. And then if I want to be able to version each instance of the blob, I want to enable that capability as well. So I've enabled that feature and come in and take a look at the storage. So I've got a storage container, do not delete. I'm going to create a new container for versioning. When you set up the container, you can enable the version for immutable support. So I've got a do not delete, and I've enabled the container recovery as well as the blob recovery at the storage account level. And I've now got a container for versioning, and it also will have the same capabilities of recovering both the container and the blobs inside of it. Let's look at the various types of deletion and recovery, both at the container level and the blob level. So if I delete the container, it now shows as deleted. You'll see that the container is now gone. By enabling the show deleted containers, you'll see the deleted container. And in here, I'll be able to undelete. I want to confirm the undelete, and now the container is back. Inside the recovered container, I have a series of blobs. I'm going to take one of the blobs, I'm going to delete the blob, and it appears to be deleted. Similar to the container, I'm going to show deleted object. You can see that I had one previously deleted. I just deleted O2, select that one, and ask it to be undeleted. And now that object has been restored. Let's return to the lesson. Welcome back from the demo. So you just saw some of the built-in capabilities, the features from the backup recovery vaults that you have, and some of the services that natively provide some of the backup in it. So remember that this is a critical part early on, and not only make sure that you've got them designed into the plan, make sure that they're being tested on a regular basis. I think I mentioned it in the demo, but you want to make sure that not only do you have these procedures going on, you want to practice the skills to recover them. I can't tell you how many people that I've had to go out to their customer locations to actually recover from a recovery that went wrong. People back up on a daily basis and they really get that muscle down. They've got that skill developed, but rarely do they ever develop the skill of recovering the information. And it typically happens at the worst time in your personal life as well as the business. Maybe it's the birth of your first child, and it's the business year end, and you're going to have to do something you've never done. So make sure that not only do you have this planned, not only do you have it executed on a regular basis, you want to make sure that you've got the recovery processes also practiced and executed to make sure that if there's any changes, you want to make sure that you architect those into your future recovery options that you're dealing with. So we looked at the full range of traditional IaaS backups of where you manage the whole service. We looked at a whole range of Azure services that have built-in recoveries, and so you can have this layered approach into your business continuity and disaster recovery, or BCDR design that you're working with. So thanks for paying attention. Good luck with building that solution, and I look forward to seeing you in a future lesson.